Hello everyone, today we're talking about Law of Sines, section 6.4 in our book. So Law of Sines, written with sine of an angle over the side that corresponds to that angle, and that is equal to each other angle over the corresponding side. So in order to use Law of Sines, we have to know side-side angle. So let's say I know side A and C, then I also have to know angle A if I want to use the Law of Sines. Or let's say I know side B and A, then I'm going to have to know angle B or angle A in order to use the Law of Sines. So basically I have to know one side and its corresponding angle, and then one other side, and I'm able to use the Law of Sines. So let's do some examples using the Law of Sines. What's great about the Law of Sines is we're able to find missing angles or sides of triangles that are not right triangles. So this is something pretty new to us. So I know angle C, I know side C, I'm looking for angle B, and I know side B. So I know side, angle, so I can use Law of Sines. So I get sine of, let's just say sine C over C. I'll write the equation down first. Sine B over B. I'm sorry, that should be lowercase b when we're talking about sides. And then plug in what we know. So sine angle C is 67. Side C is 80.2. We're looking for angle B, so I don't have anything to plug in there that. I'm just going to keep it as sine B. And I know side B is 56.3. So now I have to first divide sine 67 by 80.2. And if I divide sine of 67 by 80.2, I get 0.0115. And that's equal to sine B over 56.3. Then multiply both sides by 56.3, so I get it off the denominator, and that gives me 0.646 is equal to sine B. And then since I have a value over here and I'm looking for an angle, I do the inverse sine of 0.646. And that'll give me my angle B. So inverse sine, that's just second sine on our calculators. I'm going to show you real quick. So on our calculators, make sure you're in degree mode. And then I can do second sine of 0.646. And that gives us an angle. So that gives us an angle of, so that means angle, and this is just a sign that we use for angle, a greater than sign. So angle B is equal to 40.25 degrees. And typically we're going to round angles to the nearest whole number because when you start talking about decimals of degrees, you're really splitting hairs. So we're just going to round this to roughly 40 degrees for angle B of our original triangle. Also, that makes sense because since 56.3 is less than 80.2, this angle has to be smaller than this angle. So the larger angle is going to correspond to larger sides. So this is only 40 degrees, so it makes sense that side B would be smaller than side C. Okay, again, use the Law of Sines. So now we know side, we're looking for side, we know the angle, and we also know a separate angle. So I can go ahead and use this for finding x. All I'm going to need to know, I'm going to need to know this missing angle here, right? I need to know at least the corresponding angle with the side I'm looking for to use Law of Sines. And that's convenient because I can find that by 180 minus 102 minus 28, right? There's 180 degrees in a triangle. Even if it's not a right triangle, we still have 180 degrees. And that means that that angle is 50 degrees. So I know this angle is 50 degrees. So I had to do just a preliminary step before I can go ahead and solve for x. And now I can just go ahead and use my law of sines to find that missing side x. So I've got sine of, let's see, I know sine of 50 degrees is angle C. I'm looking for side C. Really, that's what my x is, right? Is side C. That's equal to, and then we know side A, so we're going to use sine of, not sine of A, but sine of angle A is 102 degrees, and side A is 185. So this shows we can also use law of sines if we know angle, so we know side, angle, angle. So if we also know angle, angle, side, or side, angle, angle, we can use law of sines to find that missing side. And let's see, so if I divide sine of 102 by 85, I get sine 50 over C equals, this gives me a value of 0.0053. And then I can use my trick just to switch it and say C equals sine 50 divided by 0.0053. And that means my side C is equal to 144.88. And we are going to round side distances. We're going to round sides to one decimal place. So this will round to 144.9. And that 144.9 is my side C. And again, that makes sense because my angle here is 50 degrees. So it makes sense that this side would be smaller than side A because side A has, because angle A is a larger angle than angle C. Okay, next, sketch the triangle, then solve. When they say solve, that means they want us to find all missing sides and all missing angles. So, start off by drawing our triangle. Let's see, we got 50 and 68, so they're pretty similar. Let's say A, B, C. And let's see, that we know that angle A is 50 degrees. We know angle B is 68 degrees. And they told us that side C is 230, right? Lowercase c, meaning side C. And we need to solve the triangle. So we can find this missing, different color. We can find this missing angle real easy by doing 180 minus 50 minus 68, right? Or you can add these together and then subtract it from 180, whatever works for you. And we see that this angle is 62 degrees. So angle C is 62 degrees. That's one of the pieces of information we needed to solve the triangle, right? There's going to be 6 pieces of information. There's going to be 3 angles and 3 sides. They gave us 2 angles and 1 side. We've already found the missing angle, so angle C is 62 degrees. Now we can go ahead and get to work on finding side A and side B. So let's find side C first, side A first. So we get sine of 50 degrees because angle A is 50 degrees, and we're going to look for side A, and we're going to stick using our sine C. So sine 62 divided by side C is 230. So now I'm going to go ahead and divide the right hand side, and then I can switch. So I get, actually I solve for, if I divide and switch, I get A to be 199.6. So to save a little bit of time, I'm not going to do the actual computations. You can check this with your own calculator. So if you go ahead and divide these, then switch and do sine of 50 divided by that answer, you'll get A equals 199.6. And that makes sense because 50 degrees is smaller than 62, so this side must be smaller than side C. Then let's go ahead and solve for side B. So we get sine 68, and over side B is what we're looking for. We're not going to use side A because it was an estimated figure. We're going to go with what we know exact. So we're going to say sine 62, that's angle C over 230. And then again, go ahead and do sine 62 divided by 230, switch it with B, and then do sine 68 divided by whatever that answer is, and you'll see that B is equal to 241.5. Okay, again, it makes sense. Okay, because angle B is larger than angle C, so angle B should have, or so side B should be larger than side C. So we have solved the triangle. We found all three missing parts. We found the missing angle, one of the missing side, and then the other missing side. Okay, finally, use the law of sines to solve for all possible triangles. I'll explain what they mean by all possible triangles after we solve the first triangle. So I'm going to go ahead and draw it, because I like to draw it just to kind of give you a visual of what's going on. And let's see, so this is B, let's just say A, C, and they say angle B is 25 degrees. They say side B is 25 and side C is 30. So we're solving for the triangle, so again we have to find all the missing angles and missing sides. So first, let's go ahead and let's just solve for angle C. Okay, we don't know side A, so, and we have side angle. We don't know side A, so the first thing we're going to have to do is solve for angle C, so then we can find angle A. So this is the first thing we have to look for. We have to look for, and I want to make sure I do this in a different color. First thing we're going to look for is angle C. So to find angle C, I'm going to have sine C over side C is 30. I'm going to have sine of B, which is 25 degrees, divided by the side length of B, which is also happens to be 25. Okay, then I'm going to go through and I get, after I do sine 25 divided by 25 and multiply that by 30, I get sine C is equal to 0.507. And then if I'm looking for an angle, remember I have to do the inverse of that. So I'm going to do sine inverse of 0.507 is equal to angle C. And if I do that on my calculator, I get a value of angle C equal to 30.47. And remember that we're going to round these angles to the nearest whole number. So that gives us roughly 30. And I'll fill in the triangle as we find our answers. Okay, so that gives me 30 degrees for angle C. Now I'm going to go ahead and find angle A, right? So 180 minus 25 minus 30 means that angle A is 125. Now I can go ahead and fill that in. And now I have enough information where I can solve for that missing side A. So if I want to solve for the side A, then I have to have sine of angle A, 125, divided by side A. All right, look for side A down here. And I'm going to go ahead and use the two values that I know are exact. So I'm going to go back and use sine B over side B. And I get a value of A after I do sine 25 divided by 25. I'm going to get a value, and then I do sine 125 divided by that value. So that's just simple algebra. And we get A to be equal to 48.5. And remember, we're going to round lengths of triangles, lengths of sides to one decimal place. So I have solved my triangle. I have all of the parts of my triangle. However, I have to go back to the original question, and it says solve for all possible triangles. So what do they mean by all possible triangles? Well, after I did my first law of sines and I found angle C, I found angle C to be 30 degrees. But angle C could also be 150 degrees, maybe, right? The problem with our trig functions is we know that they just give us reference numbers, right? So this angle C has a reference of 30 degrees. So maybe the angle C is actually 150 degrees. So we have to check that before I can say that this is my only solution. So I had 180 degrees in my triangle, right? My original triangle is in black. I had an angle of 25 degrees. That still leaves me with 155 degrees. So I take the reference angle, 30 here, and I do 180 minus 30, and I get 150. If 180 minus that reference angle is less than the degrees I had left, then there are two triangles I need to solve for. So, since 150 is less than 155, that means I know when I draw my new triangle, so I'll try to do my best. Let's see, we have angle A, B, C, and we knew angle B was 25 degrees. Okay, we knew side B was 25. We knew side C is 30. And now we knew in the first triangle angle C was 30 degrees, but we also have to account for the fact that this is only a reference number, so 150 can also be a degree measure for C, and 150 works. So that means, and this is obviously not drawn to scale very well, that means angle C is 150 degrees in this triangle, leaving us with angle A of just 5 degrees. So now I have to go ahead and just solve for side A, but this is my second triangle, so side A, and I'll just do law of sines using what I know to be exact. So I know sine of angle B is 25 and side B is 25. Those are exact, those are given. And I just need to find side A, so I'm going to do sine of 5 degrees over side A because I'm looking for that last missing side. So if I go ahead, do sine 25 divided by 25, switch it with A and take sine of 5 divided by that answer, I get A to be 5.2. So the side A is only 5.2 in length. So go ahead and try the example problems on the PowerPoint, and we'll talk about it in class tomorrow.